This is a video on multiplying Mclaurin series. The question states, multiply the Mclaurin series to find the first 5 non-zero terms of the Mclaurin series for f of x is equal to e to the x times the arctangent of x. So let's recall the Mclaurin series for e to the x and for arctangent of x. For e to the x, it's 1 plus x squared over 2 plus x cubed over 6 plus x to the 4th over 24 plus ... And for the arctangent of x, it's x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus x to the 9th over 9 plus ... And I just write down the Mclaurin series for e to the x arctangent of x is the Mclaurin series for e to the x times the Mclaurin series for the arctangent of x. So I look at this and I just do a gigantic FOIL, which means I distribute the 1 through all of these terms, the x through all of these terms, the x squared over 2 through all these terms, etc. But that'll take forever. Fortunately, I only need the first 5 non-zero terms. So I'm going to look at this degree by degree. So first, for degree 0, we don't get any because the second factor starts with an x. So everything's going to be at least of power 1 of x. So for degree 1, I have 1 times x. And the degree 1 term is just going to be x. For the degree 2, I have x times x is the only way to get an x squared when I multiply this all out. So degree 2 is x times x, which is x squared. For degree 3, I have 1 times negative x cubed over 3. And then I also have x squared over 2 times x. So I add those up, and 1 times negative x cubed over 3 plus x squared over 2 times x, well, negative 1/3 plus 1/2 is positive 1/6. So I get that the degree 3 term is 1/6 x cubed. So now let's work on the degree 4 term. That gives me x times negative x cubed over 3, and then plus x cubed over 6 times x. And when I work that out, I got negative 1/6 x to the 4th. So now we have 4 non-zero terms, x squared, 1/6 x cubed, negative 1/6 x to the 4th. Let's get the 5th non-zero term, which will be of degree 5. So we have 1 times x to the 5th over 5. Then we have an x squared over 2 times negative x cubed over 3. And then we also have an x to the 4th over 24 times x. So that's my degree 5 term. And when I multiply those all out and I added them, I ended up with 3/40 x to the 5th. So now I can put all of this together and find that my Mclaurin series for e to the x times the arctangent of x is x plus x squared. So here's my x squared, plus 1/6 x cubed minus 1/6 x to the 4th, plus 3/40 x to the 5th, plus ... So there's my first 5 non-zero terms of the Mclaurin series for e to the x arctangent of x. And I'm done with the problem.